Hello, and welcome to the Polar Steam Cool Connections live stream. While we're waiting for folks to join, please post in the chat where you are watching from. And if others are joining you, we'd love to know how many people are watching from your location. As you do that, we're going to go ahead and get started. I'm Jamie Ivory, the logistics coordinator for the Polar Steam program, and we are excited to have you with us today. Polar STEAM is a US NSF-funded program based at Oregon State University that facilitates virtual and field-based collaborations between polar researchers, educators, and artists to enhance science communication, bringing polar science to everyone. A recording of this live stream will be posted on our YouTube channel. Today we will focus on the team's stories and experiences understanding the carbon cycle in the tundra. However, I will mention that the 2026-27 Antarctic Artists and Writers Fellowship process is progressing for the upcoming season, and we look forward to sharing those updates on placements very soon. Applications for the Polar Steam Antarctic Artists and Writers program are open for the 2027-28 season, but they are closing soon on July 1st. Applications for the Educator program for 2027 are open and they close July 15th. And to all the researchers out there, we are currently recruiting NSF-funded polar researchers for the 2027 collaborations. I also want to share that Polar Steam is holding a summit October 1st through the 3rd in 2026 at Oregon State University in Corvallis, Oregon. We would love to see you all there. This is an in-person event. There you can strengthen your broader impacts and science communication skills, share your work in creative and engaging ways, and build meaningful networks. All right, today we are live from Toolik Station. We're excited to connect with two of our Polar Steam Fellows, Rose Cory and Karla Lopez Calderon, taking a short break from their fieldwork to join us all. We will start with a presentation from the fellows and follow that with questions from all of you, our viewers. So wanted to point out where they are. They're up in Alaska at Toolik Station, if you see my mouse moving. As you're watching this live stream, you can submit your questions live in the chat. Our team will monitor those and we will ask those questions to Rose and Karla at the end of the presentation. So I'd like to introduce you to our fellows. Rose Cory is a professor of earth and environmental science at the University of Michigan. She studies biochemistry along the land-water continuum in Arctic and temperate biomes. And Karla Lopez Calderon is an associate vice president of programs at Girls Inc. of Tarrant County, Texas. There she leads STEAM initiatives designed to empower her students through experimental learning and career exploration. Rose and Karla, welcome. Now I'll turn it over to you. We want to hear all about your experiences studying carbon in the tundra.
Hello, everyone.
Hi, thank you for having us. So I'm going to tell you a little bit about what we do, starting with, first of all, we are a huge team of scientists, educators like Karla, who's with us today, and also even an artist. Next slide. And just to orient you a little bit more, we are working on the Alaskan Arctic and at Toolik Field Station, and it's about 400 miles north of Fairbanks, Alaska, and about 230 miles south of the Arctic Ocean. So we are definitely inland here in the interior in the Alaskan Arctic, above that Arctic Circle, which is shown as red on the map here today. So next slide. Now, when most people picture the Arctic, they picture snow and ice, and that is an accurate picture of what the Arctic looks like in the winter and even into the spring. So this is a photo showing our field station, Toolik Lake field station. You can see the buildings of the field station and the ice-covered lake, and it's all snow and ice through the winter and into the early spring. But we're up here to understand this ecosystem when it's full of life. Next slide. So here in the summer, it's very green. The tundra vegetation that you can see here from a former lab member taking a sample, you can see just all this tundra vegetation, and that's what we're here to study, this ecosystem when it's alive and when things are growing and changing. And so really, what are we doing? Why are we up here in the summer? Next slide. Mainly, our goal on this long-term ecological research project is to understand how the Arctic ecosystem is responding to global change. So greenhouse gas concentrations are rising in the atmosphere, so carbon dioxide and methane, which are heat-trapping gases, and they're warming Earth. And the Arctic is warming 2 to 4 times faster than other places on Earth. And that warming is causing permafrost soils, or soils here in the Arctic, to thaw and warm. And that is releasing the organic carbon that's been trapped in these soils for thousands of years. So once this carbon is warmed up or thawed out in the soil, microbes can decompose it or turn it into carbon dioxide and methane, which of course are greenhouse gases released to the atmosphere that warm the planet, and that cycle continues. So that's an overview, but what is permafrost really? So next slide. So this is a picture of one of our sites that we study here near Toolik Field Station, and you can see permafrost shown in this picture. It's just frozen soil. Soil that's been at or below 0 degrees Celsius for at least 2 consecutive years, but the permafrost soil here has been frozen for thousands of years. In the summer, that top layer thaws and warms out a little, and that's what supports the tundra, that green tundra vegetation that you see. I like to make the analogy that permafrost, it's kind of like, food, or it's like a freezer. We keep food in our freezer, preserved, nothing happens to it when the freezer, but we take the food out of the freezer, and now we can break it down, eat it, and we take in that organic carbon, we breathe out carbon dioxide. And the same thing for soil microbes. The organic carbon in the permafrost, that's their food. And when it's thawed out and warmed up, they can eat it and turn it into carbon dioxide and methane that's released to the atmosphere. And then that travels around the Earth very quickly and can influence everybody, not just the ecosystem and people here in the Arctic. And we study the soils, but we also look in the lakes and rivers in the watersheds that are draining these soils. And we do that because soil moves. So it doesn't just stay in the soil. So next slide. So lakes, rivers, lakes, and streams, they integrate, or they capture what's happening in the watershed. And so some of the best ways that we have to understand how this ecosystem is responding is to look at the chemistry and biology of lakes, which are very abundant on the landscape. And that's what you can see in this aerial image on the right here. You can see that across the Arctic, there's a lot of water on the landscape. And zoomed in the photo on the left, that's one of the lakes that we study. And what you're looking at here is an area where there's a lot of permafrost thaw. So when ice-rich soils warm and thaw, they can kind of destabilize or form these little landslides that then release all this previously frozen permafrost soil carbon into rivers and lakes, as you're seeing in this photo. So one of our jobs is to monitor the chemistry and biology in the waters to understand how this ecosystem is responding, and then what that means for everybody here on Earth. And with that, I'm going to turn it over to Karla.
Hello, everyone. Thank you for joining our live. Again, I'm Karla. I'm the VP of Programs at Youth Vantage Alliance and Girls Inc. I'm originally born and raised in Puerto Rico, but currently living in DFW, Dallas Fort Worth. So super excited to be here with Rose and her team, trying to make a difference right here in the Arctic and try to understand what is surrounding us, either in soil or in water. So what you're seeing here is actually fieldwork. This is something that we do every day, and honestly, it has been my favorite experience so far. I'm literally just sucking water out of the soil, collecting samples. That's some of my activities and role within the team. And after we, take samples from either the soil or, directly from the water, I support the team in kind of like processing the samples in the lab once we return in the lab. Also, you see me in the other picture supporting our artists. As Rose said, we have an incredible team composed of like researchers, educators, and our artist, Nikki Lind. And I also supporting her work through recordings of like underground sounds, sounds in the water. So that's, another way that I'm supporting my team. But honestly, I think that as an educator, my main goal here is to be able to observe, follow what the artists are doing, following what the researchers are doing, and kind of seek ways to be able to take that wonderful knowledge, wonderful content, and create a curriculum and lessons that our youth, not only in Texas back home, but also across the world can use, and they can learn more about what I'm learning at this moment. So some of the things that I'm learning is about the carbon cycling, also about more about the biochemistry in our waters and how it changes with changes in the soil, changes in the permafrost, and of course, very important that our integration with our artist Nikki. Next slide. Perfect. This is actually pretty fun. The team actually created this a couple of weeks ago, and in that picture is my first time in ice, walking in ice, so that was a little bit nerve-wracking. We were capturing actually microorganisms to analyze in the lab in the microscope. So there is Jason, Rose, myself there, kind of capturing these microorganisms. And also you see the lake, or Toolik Lake, is mostly frozen. It was again a little bit scary to kind of like walk on top of it. You kind of like hear the cracks, right? But it's actually superficial. You can land a plane there again. It's super safe. It's just that, my lack of experience in that sense. But again, really fun first day, collecting samples, and we're, testing pH, temperature, right? Chloroform, so many samples to be collected in order to create this wonderful database across many years that give us a more robust understanding of what is going on in this environment, and will give us a lot of like important information on how not only the permafrost is changing, but also how is that affecting our climate per se. Next slide. Okay, that was easy for me. So again, now I think it's time for questions for anyone in the chat.
Awesome. Thank you both so much. That was really, really informative, and love hearing your enthusiasm for it all. And seeing these pictures has been really helpful as well. So where are you all zooming from right now?
I mean, right now we're in the lab, right? This is kind of like our little home here. So every day we go to the field, or, the majority of days we capture what we need, and then we return here. And again, this is our home. We process samples here, we meet here, discuss findings. So yeah, you see our incredible lab right here in the station. So we're pretty lucky to be able to have, amazing machinery and technology to process everything that we need.
Yeah, I mean, a lot of the samples, like, the chemistry and biology in the water and the soils changes quickly as soon as you take it out. And so we're very lucky here at Toolik Field Station to be able to bring all of our instruments and put them in the lab so we can run right from the lake into the lab and analyze our samples.
I think that's something that a lot of people don't realize, like remote scientific research can still be using very cutting edge things. Like a station like this really allows a lot of great opportunities for researchers.
It does, yeah.
We got a question in from a Sophie who's 15. Sophie wanted to know, how does increased permafrost thaw affect the movement of carbon in Arctic ecosystems?
Oh, that's a
That's a
great
good
question,
question.
Sophie.
Yes, yes, that's exactly what we're trying to understand. So affect the movement. So the simple understanding or general understanding is that as the permafrost soils thaw more deeply, water can move through that deeper now thawed layer and bring that carbon into small streams, which flow into larger rivers and into lakes, and ultimately perhaps to the Arctic Ocean. And as it travels through inland waters of the Arctic, that permafrost soil carbon can be decomposed or turned into carbon dioxide and methane. So, and that's what my group and many others are working on across the Arctic to understand is how much carbon will be released, organic carbon from thawing permafrost soils, and then what is its fate as it travels through inland waters? How much will go to carbon dioxide or methane, and then how much will go out to the Arctic Ocean and perhaps just stay in the Arctic Ocean, kind of another freezer.
Wow, that's so much to try to like put together and bring together as a picture.
Yes,
Absolutely.
Um, so from the chat, someone wanted to know what are the biggest drivers causing shifts in carbon storage or release in this region?
Yeah,
Warming.
yeah, warming.
Yeah.
So, yeah, I mean, the Arctic again is warming faster than the rest of the Earth, and we know that the permafrost soil temperatures are increasing over the last 50 years, and they are thawing out. And a lot of that warming is happening in the winter time, and that's important. So, that's the biggest driver. It's warming.
Um, what are some ways that something happening all the way up there in the Arctic shows up in everyday lives for people in other places like Texas?
Oh, that's a great question. Yes, what is happening in the Arctic, it won't stay right here, right? This is just kind of like, for me, it's kind of like seeing into the future because it's warming way
Mm.
faster than other places, right? But some of the models that we are learning here, we can apply locally in Texas, right? Like we're talking about more extreme weather, right? We're talking about more, meteorologically like active, seasons, right? Hurricanes. So we're talking really a big shift in weather patterns. Also, we were discussing how changes in the water chemistry can affect something that we don't even think of, like water purification plants, right? Like the water purification plants are created to be able to process and purify certain, I guess, water with certain biochemic, called signals, right? And makeup. But if it changes, then how will this affect in our local communities, how water is being purified? And, eventually if it will be actually something safe that we can actually consume. So it's not stopping here for sure.
Right. Like it's the pace of change that we see here is very rapid and it's warming faster. And so like Karla's saying, this is like a sentinel or model for what is coming. And the exact changes, of course, that we're seeing here you won't see in Texas or where I live in Michigan because the environment's different. But it's the general types of changes, like changes in weather variability or more extreme events that are impacting us everywhere. Correct. And the Arctic amplification is going to contribute to that. And then, like Karla was saying, like here we know how so much of the water chemistry and biology has changed in the last 50 years. And it's, again, it won't be the exact same changes, again, because the local environment is different in Texas or anywhere, but it's the kind of changes that we're seeing that we know now are coming to the lower 48. And these changes will have huge impacts on things that we rely on, like, because we all get our drinking water from streams, rivers, lakes, and groundwater, and that's going to change. The chemistry and biology of that's going to change, and that's going to have implications for how we have to treat our water. So, again, the Arctic it's on the front lines, and it's telling us the kinds of things to look out for and what to expect, in addition to having a direct impact on the pace of global change everywhere.
Yeah, wow. Thank you for being there and helping us get that vision of what's maybe coming. That sounds really, really important. Let's see, we got a question in for Karla. What what is the biggest challenge on water extraction from the soil to keep it like pure for scientific research purposes?
Well, in my limited experience here in the field learning, it was capturing the sample. You will literally just go into the ground and feel the permafrost almost immediately. So trying to take that sample in a way that it was correct was a little bit tricky. So yeah, so something that I utilize, right, is like I'm a physician, so I think my background in medicine came really, really helpful.
It did.
So yeah, so we work like Rose told me, hey, just think about like you're taking the blood of the earth. And I'm like, wow, that kind of like expanded the way that I actually thought about sample collection. So instead of like going like this, in a vertical, I actually like imagined that it was like a vein, right? So
Yeah,
I went
totally.
into this way,
Yeah.
right, to more. So actually the extraction of water was a little bit easier. But yes, let me tell you, field work is not easy. And you need to be very patient and try many, many ways until you find something that works for everyone. Some of the samples were pretty bad. You can see that it was like very murky, cloudy, and that's part of fieldwork, right? Some of our samples, they needed to be purified twice in order to run it and be able to have accurate results. But again, not easy, but I guess patience, being able to find a rhythm that works for you, and also learning from the experts. I have an expert here in Rose that have been doing this many years, so she has been able to coach me in finding new ways of connecting with the earth, but also finding new ways to kind of like improve the technique of picking up the samples. So yeah, but that was very hard work.
Yeah, it was, but I do say, yeah, your medical background really helped. And that's, I think, something too we want to communicate is like the kind of things that we do up here can be applied, they're very similar to what you may do in other fields. You're just, taking a soil or water sample rather than
a blood sample.
A blood sample.
Yeah, exactly.
There's a lot of similarities.
Correct.
I love that. And how inspiring, Karla, you haven't been up there for that long. How many days have you been up there doing field work so far?
I arrived on Thursday.
Yeah.
Well, actually, I think I arrived, Thursday night. So, and the team has been so supportive, and they just say, hey, let's do it. So they just threw me into the ice and, you either swim or, but it's the best way. Actually, for me, it worked perfectly because I love a challenge. So the fact that they were right there with me, guiding me, teaching me, oh, not this way, right? I was able to take my knowledge, my experience, and really integrate it with the field work. So it doesn't matter, right? Like what type of science you go into, this is something that really can connect with anyone.
I love that. And then, so Rose and Karla, you both have been working together, collaborating through Polar Steam virtually. For many months since February. And so Karla, you've had an idea about the research and the questions that they're asking, but now that you're in the field and actually like seeing that, getting your hands involved in that process, can you share any stories or moments where like something just really that helped make something click being there?
Absolutely. Yes, like you said, Jamie, I had a very good idea of the research that Rose and her team were performing. But honestly, I needed to scratch my kind of like the ideas that I arrived with. And I said, okay, let's start from scratch. First of all, it's so much robust that I imagine, right? The
Mm.
methodologies, the protocols, the knowledge. So I need to say, okay, this won't work. So needed to kind of like start from scratch. And something that I actually needed to do was to divide the knowledge. So talking about the carbon cycling is such an important uh, piece of the puzzle, right? But I think that I was maybe not thinking so much about the history of the land, the changes that had happened, right? How these like weather lands have affected right now the biochemistry of the water. So now I have like two sets of like lessons more into like the biochem and the carbon cycling, but also learning about the Arctic, right? The polar regions, the history, how it was formed, because I think that's type of like historical data and knowledge is so vitally under to understand the carbon cycling. So I'm pretty much like needed to start from scratch. Which is amazing, right? Because it means that it was so much more than I expected. And I want to be able to introduce my students and the youth that I will be teaching into really like the complexity of the whole polar science world.
And I feel like this is such a phenomenal team to be thinking about that historic aspect and then the complexity because Rose is on a long-term ecological
Yes.
project. And so, Rose, can you talk a little bit about what is how do long-term data sets like the LTER project help answer questions that short studies just can't?
Yeah, that's a good question in so many ways. I mean, the long-term monitoring is really the gold standard, we'd say, of science, of understanding the environment. So we do, I'll explain why. I mean, but we do experiments. So we'll take soil and water samples and we'll do experiments to test our hypotheses about how things are working. But what really tells us if our experimental answers are correct is by looking at the landscape, by doing this long-term monitoring. Because the environment then is telling us what's happening. And we just have to be, prepared enough with good questions and good understanding to interpret the signals that we're seeing. And I mean, there's a couple examples of that, like on the LTER here, our long-term ecological research project. Like one study that I wasn't involved with, this is before my time, where they were testing ideas about how thawing of permafrost soils may affect the biology and chemistry in the rivers and lakes around here. And so as permafrost soils thaw, they release nutrients like nitrogen and phosphorus. And so the group here started adding phosphorus to a stream to say, okay, let's try to understand how this ecosystem might change. And they really didn't observe much for 13 years. So they were adding phosphorus, continually, nothing. And then all of a sudden mosses appeared after 13 years. And so, that's the kind of research that is you can't do on a typical short science project. Most of our projects in science that are funded are 3 to 5 years, right? So if we had done that over a typical cycle, we never would have got the right understanding about this environment. And so long-term monitoring allows us to do, these really long-term both experiments, but also data, because things in the environment don't happen on our time scale, right? They happen as they're happening. And so we have to be prepared and continually monitoring and revising our understanding as we're getting new data. Like, for example, now we have a 50-year and 15-year record, depending on which exact chemical signal that we're looking at. And we're seeing the chemistry in the lakes changing in some predicted ways, and then also some really surprising ways that we would not have predicted. And it's only that long-term monitoring that allows us to see that. So it's really vital.
Yes.
Yeah, sounds like it. Thanks for explaining that. I think that is something that, not many people even know that we have these LTER projects and how very valuable they are.
Yeah.
Let's see. Another question from the chat. This is for Rose. Since it's a little warmer there, do the polar bears try to open your doors and chill with you guys?
Well, and no, but it is something that I do worry about because
We do worry about it.
but we really shouldn't. So we are 230 miles south of the Arctic Ocean here at our field station, Toolik Field Station, where we work. And the polar bears live on the coast. They live, on the Arctic Ocean. So that's where their food is. That's where their habitat is. That's where they make their life. So they would have to travel 230 miles south to find us. But one did in 2003. I wasn't here at the field station.
Thank God I wasn't here either.
But just knowing the fact that at some point one has, when it's like early spring and we're here and it's all snowy and white out, I'm always like, is that a polar bear? But it's not. But we had a project a while ago where we were sampling one of the rivers here that starts in the Brooks Range, just by us here at Toolik Field Station, and it flows all the way to the Arctic Ocean. And so we were flying by helicopter and sampling the river from where it starts in the Brooks in the mountains all the way across the foothills to the coastal plain to the Arctic Ocean. And from the helicopter, my students did get to see a polar bear, which is the only way I would like to see a polar bear from a very working, functional helicopter
from
in
air. Yes, absolutely.
This is a question, it says specifically for Rose, but I would love to hear Karla share as well. What's the weirdest or funniest thing that's happened while doing field work?
Oh, that's a good one.
That's a good one. So many things. Weirdest or funniest thing. Boy, I'm gonna have to think about that.
Yeah, this is a very good one.
So many things. I mean, from just little things like, we get, as scientists, we get so excited to share what we're doing. Because we love working up here. And so one time, like this was, 10 years ago when like GoPro cameras were like all the rage, and now we can use our cell phones for everything. But we attached a GoPro camera to the helicopter to show what it looks like, flying over this incredible landscape, from the mountains to the Arctic Ocean, and just so exciting to communicate what we see, which the things that very, very few people get to see. And but and we're doing work all day, and of course we're in a remote environment, and I forgot that the camera was on and I had to use the bathroom, and I went away from the group in front of the helicopter where the camera was. So anyway, there's things like that, which I've just shared now with the whole world. But science-wise, also, we see amazing things up here, like the rivers sometimes turn red and pink, like the colors of our shirts from various things happening in the watershed, which is absolutely incredible and weird and wild. And I can talk about that, but yeah, I'll stop and bury myself.
I think also the sounds, the work we have been doing with like Nikki and her sounds has been pretty cool. Very.
Oh, hold on, the sound cut out on you for a second. Let's see. Sorry about this, everyone. Looks like we're having some sound troubles for Karla and Rose. Maybe want to try to like take the camera off and see if we can hear you. Oh, wait, you're back. You're good.
Okay, perfect. Yes, probably our Wi-Fi. So yes, sorry about that. Yeah, we have a little bit of an unstable connection, but you just let me know. Some of the, I think also weird stuff that we have encountered is that while working with the scientists and our artist, Nikki Lynn, we have been recording sounds underwater, right? And you will think the water and the, the movement will be certain frequency, but then it's a complete different weird sound, right? That you never expected it. Also very concerning. We were, I think, 2 days ago in Navid.
Yeah,
Navid?
and
Yes,
yeah.
yeah. And we, put the microphone kind of a little bit deeper into the water, body.
Into the stream.
Yeah, a little bit, yeah, into the stream, but a little bit deeper. And we just starting hearing like scratches, like sounds. We're like, this is weird, and was not expected. I try to move away from that body of water pretty quick. But no, nothing was there. It was just like the most amazing like sound frequencies being captured by the mic, and but definitely extreme something that you really don't think it will sound like that. So it was really special, yes. And it's kind of scary at the same time.
Oh, so you mentioned the shirt. So,
Oh, yes.
love to hear a little bit
What were
about
you
the
saying?
shirts you're wearing.
Yes.
Yes. Okay. Well, yeah, I'm
Some
gonna let,
representing Girls Inc.
yeah, and I'm gonna let, yep. And this is also Girls Inc. Cool marshmallows, polar steam. I'm gonna let Karla tell the story of this shirt.
So when I got accepted into Polar Steam, the girls I work with, all girls, so they were extremely excited and supportive of what I was going to, be doing up here.
Sorry,
And
and you mentioned the girls you work with. Are these
yes.
colleagues or are these your learners you're talking about?
Okay, these are my learners. So specifically our girls from AV Cato Elementary School at Castleberry ISD in Fort Worth, Texas. Specifically this class, right? And actually I believe it was like fourth and fifth, the fourth and fifth graders. So I was there sharing that I was going to be in the Arctic, everything that I was planning to do. And they were super supportive, very excited of our project, and they wanted to come up with a name and also a logo for our LTER team, right? I think we are LTER Arc Aquatic, a very long name, right? So not very, not the coolest, right? Not very kid friendly, right? Very scientific. But the girls really felt very connected with the team immediately, right? And connected with our mission here. So we actually took time to create a competition. They're very competitive, they're very creative. So they actually voted for the name. And there were pretty cool options, but they actually decided to go with cool marshmallows. Cool, of course, right? Arctic, but also marshmallows because they were thinking of the puffy jackets of us, using it here. Although we have been mostly in t-shirts, right? But we have that, idea of the big puffy jackets, especially in spring. So we went with cool marshmallows, and they actually designed the logo too. So what you are seeing is the incredible work of our AV Cato Elementary girls, kind of like through Girls Inc., creating these special kind of like collaboration, right, with the LTER. And I think that way there's a little part of them up, here in the Arctic with us, and kind of like that give us the drive and the motivation to continue working on our, experiments and the overall goal that is understanding, the Arctic environment.
Oh, that's such a great story. And I love that the whole research team has t-shirts and is wearing those. Love that picture at the beginning of the slideshow of
Yes.
everyone in
We
the
went with
shirt.
pink. I mean, there's no way to go wrong with pink. So we had a blast, and the whole team, knows about the story. And again, I think that made us even more connected to each other, and that what we do here, it doesn't stay here. It really travels. It matters, and it matters to a girl in Puerto Rico. It matters to a girl in Texas. It matters to a girl in New York, right? So, that's what really keep us going, and make sure that we work hard every day to provide the best that we can.
That's wonderful. We have a few, maybe we could do like one more question from the chat. Let's see. What advice would you give to someone who wants to do this kind of work? I think both Karla and Rose, you could answer this.
You want to go first?
Sure, let's do it. I think never being afraid of following something that is unknown, right? Like myself coming from an island, who will think that I would be here in the Arctic, right? But I think something that I've always have tried is to follow the nose, right? Follow the what is difficult, the challenge. That's the way to go, because that's the best way to really explore, learn, and grow. So I think that the main message that I will say is to feel free to feel empowered to go after those challenging situations, right? Because there's a space for you here. There's a space for you in science. There's a space for you, as a polar educator or a polar researcher. But definitely it will not be in the path of least resistance. It will be in those places that are challenging, hard, and to feel that you can definitely belong there. So that message of empowerment to our youth, I think that's something that I would love to continue, providing.
I agree completely. And so, yeah, like if you are interested in polar science or, Arctic carbon cycle science, like what we're doing here, there is no one right path. There are many, many paths. And that's kind of the fun thing of being about at this field station is you learn that nobody here got here by the same path. We all came by different ways. Lots of trial and error, lots of challenges. But if you like science, engineering, art, education,
Yes.
there's a place. And within science, we need people who like math, physics, biology, chemistry, geology. There's always like we apply all of those concepts here. So you don't have to be good at all of them. Just, find what you like and stick to it. And like Karla said, always go for the challenging route, because that's going to prepare you most. And I think like, because there's no one path, it's important like to find your own path and to not like let other people tell you need to do this. I mean, you can always, reach out, find a mentor, but perhaps not, listen to what you want to do and stick to that, even when people think, I don't know if that makes sense, but it's the most fun happens when you take the path of least resistance and the challenging path. I think we would agree on that.
Yes.
I love that. Follow the challenges. I think that's amazing advice for anyone in
Yes,
any
absolutely.
stage of their lives. I love that. Thank you. Well, we are about out of time. There's a couple of questions we didn't get to from the chat, and I do apologize to those viewers. But we have run out of time, and we want to let Rose and Karla get back to their important work up there. Thank you both so much for taking the time to share your science and your experiences with us all. We hope that the rest of your field work goes super well.
Thank you so much.
Thank you so much.
Yeah.
And thank you to everyone
thanks for
that
watching.
joined our live stream. We truly appreciate it. See you soon.
Okay, so thank you again to all of our viewers for joining us and asking such insightful questions. Oh, am I sharing? Let me see. I did not fully get that. Okay, there we go. Okay, thank you to all of our viewers for joining us and asking such insightful questions. There are so many ways to engage with Polar STEAM. You can subscribe to our YouTube channel. You can follow us on social media at Polar STEAM Team. To see our blogs, educational resources, and program information, check out our website. As a reminder, this recording of the live stream will be posted on our YouTube channel for you to view again or bring others to view and share out. We'd also like to invite you to join us for our next live stream, the Cool Connections, that will begin that will be on July 22nd at 11 a.m. Pacific time. Details and links to that will be available soon, but I can share now that we'll be in Prudhoe Bay, Alaska, to learn about saltwater intrusion. Thank you for tuning in to Polar Steam's Cool Connections today, and we hope to see you at our next one. Bye-bye.